Hello, everyone. First, this session is being recorded. My name is Victor Monga. Welcome to CSALA chapter online meeting today. The QR code on the screen can point you to CSALA social media and YouTube channel. All of the slides and recording from today's session will be posted on our social media and YouTube channel. If you have any questions during the session, please post it in the Q&A box.
Okay. Hi, everyone. As Victor mentioned, my name is Whitney Carlin. I am an account manager for Palo Alto Networks in the Los Angeles territory. My focus is around supporting companies that fall within the SaaS vertical. We are very excited to be able to participate today and look forward to partnering on more events in the future. The QR code on the slide will take you to a quick survey, and upon completion, you'll be entered into a raffle where the prize is a $100 gift card. So as long as you complete that by end of day, you will be entered into the drawing.
Awesome. Thank you, Whitney. With that, I'll pass it on to Jason.
Thanks, Vic. Good morning and afternoon, everyone. Thank you for your time today. I hope you get something out of this. As Vic said, that this is a very relevant topic right now for all of us as far as business continuity and scaling for remote workforces. One of the things that I will say is that we're all dealing with this on some level, right? Whether it's work related, so that we're working from home and the stresses of working from home with the entire family being home, or even perhaps we know a loved one or a close friend that has contracted COVID-19 and has fallen ill or even passed away as a result. So this is a challenging time for everybody, regardless of what position you're in, and it's a global thing. So if there's something we can do to help, this is what we're here to do. If we can take some of the day-to-day strain of your IT roles off of your back, so you can focus on some other things, I think that's incredibly important. So without further ado, I'll go ahead and get started into the discussion. So what we're talking about today is something that we really have, in a way, tried to deal with or thought about dealing with in the past, right? So we previously looked at things like avian or bird flu and H1N1 and all these other things that started bubbling up, and we were like, uh-oh, this could be a problem. So what did we do? Our IT teams, and I spent most of my career on the IT side, so I was one of those people looking to plan for a potential pandemic situation. But what did we do? We looked at how is our remote access environment structured? What do people need to access? For how long? At what times of the day? And things like that. It got to the point where we carved things up. Okay, maybe a bunch of executives only need email access for a few days, and we'll see how it goes. And maybe this group over here needs access to 1 or 2 or 3 applications, and we'll see how that goes. Well, we're 8 weeks into where most organizations, especially out in California, have really kind of instituted mandatory work from home, shelter in place orders and things like that. So there's not a lot of leeway as far as what we've been experiencing to date. And we don't know when this is going to end, right? This is a new challenging time for all of us. And with that, it's where do we go from here? Making sure that we can address the issue that we're facing today, which is making sure we can get our users working productively across all the applications that they need access to. But then how do we make sure that we're ready for this if it happens again, or, wave 2 or 3 or whatever winds up happening, or a completely different event, where we're focusing on making sure that we have the ability to have our users working remotely, but productively. So before all of this really kicked off, these are some of the observations I had. We were already seeing organizations leading towards cloud first, mainly because of the way that the software industry was going. Right? Software industry wants people to consume their product as a service, right? And that's from a licensing perspective. That's from controlling variables like the hardware that it's running on, making sure that systems are patched and all those things that are why we would call software vendors. Oh, something's not working. Well, did you update to the latest this? What hardware OS are you running on? All of these things. And it was like, oh, well, I guess I didn't do all those. So eliminating variables to the success of the product itself, perpetual licensing from SaaS. That's what's been driving it a lot. But also, it's the fact that it makes good business sense in a lot of ways. Unless you run data centers as your corporate objective, nobody really wants to. It's more of a necessary evil. So how do we turn funding and operational effort towards more productive things to the company itself? We've always had some type of gateway limitations when it comes to VPN. So we either dealt with that or we figured we'd upgrade if we needed to quickly, whatever it is. But we kind of ran for a long time after those pandemics that I talked about kind of waned, right? We didn't see them happen. We rested on our laurels and said, okay, we're going to use the capacity that we need. And that's really about it. We're not going to, triple capacity just in case. We did that once, nothing happened. We can't spend that kind of money again. So since we've been dealing with VPN scale limitations, backhaul is a bad thing for user experience, whether that's localized content for those of you that run in multinational organizations or global organizations where, language specific things are required, so local egress in those countries is preferred, but also just long haul from remote access in general. Just the need to connect up, a couple 100 miles away from a data center for accessing an application can be problematic, especially when now 85 to 90% of our workforce is accessing the same app that way. And then the overall, look, VPN is not secure. Either are software-defined perimeters. When you look at them by default, they provide secure access to something, meaning that they're, even VPN is an IPsec tunnel. So the session itself is a secure session. But what's happening within that session is a problem, right? And it's especially true when we're talking about the insider threat, the internal user that may be trying to do things maliciously. How do we make sure that doesn't happen? Because policy checks and validation of a user are good as long as that user's behaving properly. If that's a known user that is a bad actor or something like that, it introduces a whole new set of things. But so that was all before this started. But now, since the last 8 to 10 weeks, this is really what we're seeing. A lot of companies I talked to today, they said, look, we identified risks by having some of these applications still sitting in a data center because they weren't elastic, right? And everybody trying to VPN into a single data center to access these things, horrible, right? The performance is bad, or the app's breaking down, all these types of things. It's not good over long haul latency connections, whatever it could be. Apps are not mobile friendly, right? So when we talk about sending people home and they maybe didn't have laptops, they were desktop users. So we're trying to get them, working with a more mobile type and a more mobile type environment. The inherent or homegrown apps, don't have clients, for the endpoint. And two, it's the path to these services themselves, the internet being the more efficient path. When we look at this VPN scale, right? So we were talking about probably 30% of users and across most organizations that allowed their, users to work from home, or 30% of their workforce were allowed to work from home or work from anywhere. That's jumped to all knowledge workers. 85% within a lot of these organizations are now working from home. The tools and apps that are in use, right? So productivity and collaboration. These are things that we didn't really think about before, or that we split off of VPN, but now with everybody using them, we don't necessarily want things to run unsecured or uninspected and that type of thing. So it's causing a problem. And then the hairpin between a user going into a VPN data center, VPN gateway in a data center out to cloud and SaaS, and then the return traffic, it's just adding a whole lot of congestion. The localization loss that I talked about before with backhauling, splitting VPN traffic off to help with capacity issues that may be experienced, but then now we're losing visibility because we're bypassing the security controls in place for those things. And then the VPN piece itself, like I said, we're trying to get users on and working as much as possible, but we're now trying to figure out how to go back and address security, because step one, get them on, get them working. Now, step two is how do we secure it? And so when you cut across all of these, what were some of the drivers? Look, the shortage of laptops, like I talked about, when everybody was trying to order them at the same time, they couldn't get them, right? So unless you were Chase Bank or Bank of America or GE, you weren't getting laptops as quickly as you needed to. And so with that, we were struggling to get users working from home properly, fully in that fully productive way. And by the way, we've talked about it a lot when we talk about cloud access, and users are not sitting in branches as much anymore. Users are all over, or applications are all over the place. The internet's becoming that more common connectivity piece rather than a wide area network. Well, that's no more present than obviously today, right, where everybody's working from home over their broadband connection. So some of the challenge with existing remote access options, we've got full tunnel VPN, which we're talking about, not being scalable enough. There's one piece of that, which is adding VPN concentrators to your environment, so that you can actually scale the head ends. But what about the dependent infrastructure, right? You've still got the ISP connection coming into your data center. You've got your edge or border routers. You've got your load balancers, switches, IP address pools. There's a lot of things that have capacity limits as well that need to be taken into account when you look at increasing, your typical VPN deployment. So, and there's split tunnel VPN like we're talking about. Let's just send only what's actually in the data center to the data center. Everything else we're going to split off, but obviously that's creating risk when we're not inspecting that traffic or we're losing visibility of it. And then we can look at adding point products. So maybe we've got a remote access solution today, and we're going to add another one to do something else because we just can't scale what we have any further. So now you're starting to add product after product after product that may not all be working the same way. Obviously, they have different policies, different clients that you're trying to roll out and manage. It creates a mess, right? And it's complicating what we're trying to do instead of simplification, which is a goal that we had, well before all this started. So taking a closer look at split tunnel versus full tunnel VPN, what we're talking about is pretty clear. I think, sending all traffic into a data center for inspection of that traffic is what a lot of organizations have done to date. But when you're talking about a much smaller footprint of users accessing services that way and throughout different times, right? Not all remote users are peak users. Let's put it that way, right? Where, yeah, you have morning users checking in, checking email first thing in the morning, doing that type of thing. But then you'll have patches on and off throughout the day in a normal working environment where, somebody's back on or accessing this app, or if they're road warriors, they're meeting with customers or clients and they're coming back to the hotel or a restaurant to do some checking in and doing other stuff. So it's sporadic. It's not as consistent as it is right now, where things are getting hammered right at the same times every day because everybody's got their routines or everybody's video conferencing at the same time and those types of things. So then, like I said, if you're split tunneling, you're losing some visibility, which is a security gap. So how do we take a look at this? This is the challenge that we're facing, right? When everything was the way it was, you were looking at mobile user traffic or ingress traffic as the green arrows, and then egress traffic from the data centers, that yellow arrow going up. So now all of a sudden, everybody is working remotely or from home, which is good for the branch traffic. So we've reduced that piece. Branch source traffic is going down, so that's taking a load off of the egress capacity, but it's just shifting sand, right? Or maybe in the first place, those branches had direct access to the internet already. Great, but now if it's shifting sand, we already had some level of capacity. If we were already sending that traffic direct, this is net new capacity to this VPN gateway and hairpin situation. So we can try to address that by scaling the VPN concentrators, like I said, but then it's the gateway itself that is having the capacity constraints. And this is what's impacting business continuity right now for a lot of organizations, is the fact that they just can't get equipment in fast enough, or they can't get their ISP circuits upgraded fast enough. Their orders are in, but hardware is sitting on dock somewhere or on a truck somewhere. It hasn't reached your facility. And then even when it does, you need the time to rack, stack, power test, and then add it to the production environment. All of this takes time. So what are some of the solutions we can help with, right? So look at it this way, start by looking at what you want to be able to do today to solve the problem, but then making sure that we're ready for whatever happens next. And two, just what projects were already in flight before all of this kind of took over. right? So we want to make sure we're providing a more direct path to cloud and SaaS. We want to make sure that security inspection is built into what we're doing, not a bolt-on or an after the fact. We want to offload that inbound capacity to a cloud service that's auto-scaling if we can. I mean, that makes a lot of sense. Get greater capacity when needed, give it back when we don't, right? That's intelligent usage of a cloud. Globally distribute those remote access entry points if we're a global or multinational organization. Don't have them just centralized within, California or the United States or North America even. Make sure that we have a good on-ramp, as close to the end user as possible, wherever they may be in the world. And then making sure that zero trust network access is capable. We want to make zero trust is a strategy. It's not a product, but the products that you choose in that strategy can set you up for maximum success. And then let's look at consolidation, right? When we were talking about maybe an option for some is adding remote access solutions. And what I mean by that is, some of you may question that statement. I just got off a customer call, right before this one. The customer is using a VPN, a traditional VPN solution. They're using a software-defined perimeter solution for some users. And then they've got, some type of VDI, whether it's Citrix or Microsoft RDP or something going on. They've got 3 or 4 remote access solutions right now. And some users are using both. Some are used for a specific type of user, but it's very complicated and it's not always necessary. There are arguments to be made for a VDI type environment, but for all else, you can probably step tier your remote access with the better solution when you start to consolidate down to the right one. So how are we looking at this? We're looking at this. The product we're talking about today is Prisma Access. So Prisma Access is our cloud delivered firewall solution as a service that is meant to connect all users to all things. It doesn't matter where the data is. It doesn't matter where the user is. It's secure connectivity. So security is built in. It's not bolted on. And it's using an efficient path between user ingress and egress, which we'll talk about here momentarily. So our approach, you saw the other, the drawbacks to the other 2 solutions. Prisma Access being a cloud delivered solution, we can deploy it quickly. For your remote users, it's as fast as creating a policy for your users to access what they need to access. And that's whether it's in the data center, cloud, SaaS, or internet. And then deploying the client onto their endpoint. So a lightweight client that is building an IPsec tunnel to the Prisma Access cloud. And it's a single client and a single solution, no matter where your users are going, which I'll explain again in more detail further. But the idea is, right now, a lot of remote access solutions or cloud delivered security solutions are grouped into 2 buckets, internet security and then private access. And they're 2 different products. They may use the same endpoint agent at the end of the day to get the traffic steering to one place or another, depending on where the user's going. But they could be steered to 2 different clouds, right? One could be the internet security cloud. One could be the remote access cloud. And with that, there's probably 2 different user databases, no rationalization of policy between the 2 solutions. That creates complexity, even within the same vendor, right? So what we want to make sure we're doing is just providing access. We look across the board at what a user needs what services a user needs access to. Data center, cloud, SaaS, doesn't matter to us. And we let the cloud do the routing. One cloud, one solution, one client, and then the user goes wherever they need to. So how does that look? If we take that previous drawing that I showed you a minute ago, this is augmented a little bit, with public cloud, SaaS, and web drawn out. But overall, the spirit is the same. If we now broke this out and shifted the data center left a little bit, Prisma Access being a cloud delivered capability, you can envision this as being essentially your new hub, right? So if you look at everything else as a spoke, and that's branches, users, data center, cloud services, they're all spokes hanging off of an edge interconnect. And that's what we're trying to do. This is the idea behind Gartner's term SASE, which we'll talk about too, Secure Access Service Edge. It is a means of connecting users and their services at the internet edge, right? In a more cohesive way through a single platform. So now, instead of everybody VPNing into that central gateway, they connect to the closest edge location as possible, and then they let the cloud route them to where they're going to go. Not only is the cloud routing them to wherever they're going, so we don't care where it is, but they're also leveraging the cloud's fiber backbone for transit. So this is improving performance and eliminating that middle mile variability that a lot of other solutions inject. So you've got your first mile, which is the user connecting to the service. Then there's the transit within the service itself. That's your middle mile. And then you've got your handoffs from the service. And then your last mile is from wherever that's egressing to the destination. And so if you can control that or minimize the variability of that middle mile, it's incredibly important. If you think about, like, just do a speed test at home during a peak time, right? So if you've got kids at home and they're either, at school doing online learning at the time, or school taking a break and streaming Netflix or a game of some kind while you're working and everybody's working through the same broadband connection, see what percent that you're actually paying for out of your broadband connection that you're getting. I'm getting about 10% at peak times, so not very great. So we talk about now trying to access SaaS and cloud applications, even split tunnel VPN, where you're splitting it off, but the effort is best at best across the internet. So you could have anywhere between 3 and 40 hops to get to that next SaaS destination because of that variability of what the internet is just experiencing right now with all this broadband usage from users at home. Our cloud can eliminate a lot of that middle mile variability. So that's where you're getting that benefit. But it's not just transit. It's, like I said, inspections built in. That's that little magnifying glass that's at the edge of each of those things, including now when things start to return to normal, or if you do have branches on, you can connect them up to the cloud as well to do site-to-site traffic between your sites with security inspection built in, or just providing that more efficient path to their destination, if that's cloud, SaaS, or web. So you're eliminating that data center backhaul of WAN traffic as well. So talking a little bit more about that secure access service edge, really Gartner came up with this over the summer, last summer that is, and it's really not wrong. I like where they're going with this. Some people question Gartner's motives with certain things of relevancy and things, but they're saying, hey, to the security providers, hey, to the network providers, get your stuff together, and why don't you consolidate services into just a platform-based approach for edge connectivity. And so that's what we've done. We've been doing that for a long time. Now it's formalized in a space called Secure Access Service Edge. So this is where we play in it. Prisma Access is handling this at both the security as a service layer and the network as a service layer, where your security services that are incorporated in this are embedded, right? So this is what I'm saying by built in, not bolted on. So from the network layer, you've got your SD-WAN capabilities, your IPsec tunnels, whatever they are. But from a security perspective, this stuff needs to be baked into that transit, right? And the 5 core components of SASE, according to Gartner, are having a CASB for your SaaS security, zero trust network access, a cloud secure web gateway, firewalls as a service, and SD-WAN. We provide all of these. So we launched our SD-WAN capability back in November, which was native to the Palo Alto platform. But we decided that we could do this a little bit better through an acquisition. So as many of you know, we purchased CloudGenix, which just closed officially 2 weeks ago. So we're continuing to integrate CloudGenix Cloud SD-WAN platform, their cloud hub, into Prisma Access, so that we can provide that seamless platform experience for both software-defined wide area networking, as well as having the security included in it. The way we've architected the cloud, like I said, not building one, but using public cloud services. So we do use GCP and AWS to deliver this service to all of you, which gives us great scale capabilities. So not only do we have the ability to auto scale where we need to, which I'll show you momentarily, but we can give dedicated customer instances so that nobody's sharing resources or bandwidth, between other customers hitting the same physical data center. So things we're doing there. But it's the use of these services that are giving us the ability to provide certain levels of SLAs as well. The first one that we have that is really good is our security processing time. So our security processing time SLA is guaranteed to be under 10 milliseconds. So that's running through all of the services turned on at the same time: SSL decryption, sandboxing, DLP, DNS security, all of those things, URL and content filtering. Those are all running under 10 milliseconds for security processing. But then we also have a SaaS SLA. So this is this is guaranteed performance to certain SaaS applications. And we have 5 right now. So Salesforce, Office 365, G Suite, Slack, and Box. So the 5 in the globe there. We are planning on expanding that, but these are the first 5 that we've certified. This is all, in black and white in our SLA that's publicly available. The link is there on the screen. But we're able to achieve these SLAs because of using public cloud services with that cloud fiber backbone as interconnect between all of these services. And because it's AWS and GCP, we're natively peered with Azure and AliCloud and others on the internet backbone. So we have tier 1 peering built into all these other cloud service providers. That's why we're able to provide good experience to, or best in class experience to Office 365. And think about all the SaaS providers out there that host their services out of Azure, GCP, AWS, and IBM, and all of those. So we have natural tier 1 peering to that SaaS as well because of where they're hosted. So all of these things equate to a really good user experience plus the performance of security built in, right? So we don't just provide good performance with no security turned on. Everything is turned on with Prisma Access by default. So how do we connect users up to Prisma Access? It's pretty simple from a managed device perspective. We have a client that sits on the endpoint, supports all clients other than BlackBerry, but we push that out, users connect up. So this is what users would be accessing Prisma Access from home with. And then for the unmanaged or BYO devices, we do have a clientless or browser-based option. Now, what we do have is a situation where, like I said before, laptops can't get out fast enough, and maybe the client-based session isn't providing enough access to enough applications, and that's understandable. The option that we're giving customers now, it's not something we really wanted to do just due to risk, but we can deploy the Global Protect client on a home PC. So an admin can send out a link, it's installed, you provide your SSO credentials, MFA, whatever you do, and you get your VPN profile that you would have, if it were a managed device. The reason we don't normally publicize this is because that's a terrifying thought, putting a home PC on a VPN. But our VPN is not a traditional VPN. Our VPN terminates at the access point through a firewall, doing full layer 7 inspection of the traffic. So the user, when they connect in a Prisma Access, is connecting to a firewall, not a VPN concentrator with a firewall behind it. So what this is doing is it's allowing us to take a not risk-free, but reduced risk approach to home PCs being attached to our service. So we're doing full malware inspection, data loss prevention, and everything else across this upon connection, and through the session. So like I said before, the session is inspected end to end. So that reduces a lot of the risk that you would normally have by just putting a user on your VPN network, and then the user can have malware that crawls across from there. With our user ID and app ID capability, you can get as granular as you want, one-to-one between a user and an application. You define that as you would a software-defined perimeter solution. So you've got your user context, a validation of who they are, the device they're on, device posture, location, whatever profile you want to set up for your host information. And then based on policy, once all those HIP checks are granted, they're granted access to that, or once all those HIP checks are approved, the user's granted access to the application or service by policy. So that's your typical software-defined perimeter approach. But like I said, because of the insider threat potential and things like that, we are also doing full layer 7 inspection of the session itself. So it keeps you out of danger. So what does our architecture look like? So it's a truly cloud-native SASE. Like I said, you can't be more cloud than leveraging cloud services to deliver the service. But that gives us global distribution, over 100 POPs globally, 76 countries. We're software-based, hardware neutral. So our platform started as the PA Firewall series, so our proprietary hardware and OS for our firewall. Years ago, we abstracted the software to make it hardware neutral, and that was what became the VM series. From there, we've now taken it and made it cloud agnostic as well, and that's what Prisma Access is. So it's the same firewall code and software, now consumed as a service. So same security capabilities. For those of you that are next-gen firewall customers of Palos today or VM series, it's the same firewall code. It's all managed through Panorama. If you, so Prisma Access just shows up as what looks like an object group through a plugin to Panorama. So you build your policy still once, and then you extend it to however you want. It also it also is integrated with any other mobile user gateways you may have set up with Palo Alto Networks. So if you set up GP, Global Protect already for your data center environment, and you want to scale that with Prisma Access, you can do that as well. Single pass scanning for threats. So just like our traditional firewalls, it's a single pass architecture. So the session state is consistent for the user. It's a stream rather than a series of processes. And then we do inline encryption or decryption and re-encryption at scale. So we do that SSL decrypt and inspection for all traffic, at least everything that you're willing to allow by policy. And then, the biggest thing that I'll say here is, we do scale out and back as needed, which is what everybody's experiencing right now. It wasn't necessarily built for this, right? But it happens to be a benefit that we can take advantage of today. So how that looks from a tenancy perspective, multi-tenant management. So all of our instances are customer based. So every new customer that joins on the Palo Alto Prisma Access gets their own instance. And with that, we manage it through Cloud Ops and APIs. So we watch that instance for traffic, we watch it for a bunch of variables, and we can increase it on demand as the event requires and descale it as needed. And we can do that because we're doing it per instance, right? So per customer instance, we're not trying to buy a bunch of, 2U servers, throw them in a data center and call it a cloud. And the only way to scale that cloud is to continue adding server after server after server. We're leveraging auto scaling capabilities that come with the clouds that we're provisioning the service for you from. So how does that look in the event of large event saturation? So say you've got 3 customers all hitting the same cloud, right? Customer 1 has a big event, so they're continuing to grow and scale their instance as needed. So we're doing this through APIs. Like I said, they're managing or watching thresholds, and as that threshold is approached, we increase the instance automatically. Nothing that the customer has to do. They don't have to call us and say, hey, we're gonna have a web event, or we're gonna push a software update out to our laptops. Can you make sure we have enough scale? It just happens automatically because of using the elastic compute that these cloud providers have. So it scales up as needed. Customer 2 had nothing going on, so they didn't scale at all. Customer 1, again, had a big event. Customer 3, a medium-sized event. But then when it's over, they scale back down to what they need at the time for that usage. So this is efficient use of cloud, and that keeps our cost of the service low, so we can provide, a more efficient cost structure to our customers as well, instead of just, continuing to, build and build and build data centers. So how the connectivity architecture looks, this is how we connect to the services up at the top. So where our SLA is granted, again, because of that tier 1 peering arrangement, but we do peer with all the clouds. We reroute users to the internet so to replace your secure web gateway capability through your customer's egress IP, or our customer's egress IP, your egress IP. And then we have connections into the data center that's called a service connection for bidirectional traffic to and from the data center to these services as well. So if you've got data center to cloud traffic, or if you've got user to data center traffic, whatever it is, that's how that happens. And then users connect up. No matter how we connect them, we try to do it as securely as possible. So we use IPsec, both from the branch perspective and from the customer client or the end user client perspective. Our single pass processing looks something like this, right? So we've got layer 2 and 3 networking that comes into the environment. We apply user ID, so we identify that user. So this is part of that, that more software-defined perimeter zero trust network access look and feel. Who's the user? Are they who they say they are? Can we provide context? Okay. Then we move on to app ID. What applications do they have access to by policy, right? And making sure that we understand that they only have access to the applications by policy. So now once we know that, now we can apply content ID. So this is where if you have full GP access, so full Global Protect clients running on an endpoint with full access to all their applications. But then you've got a BYO scenario for their iPhone or Android device or iPad, they only access, or maybe they access the same apps, but only certain capabilities within that application. You can apply that through Content ID. So it's a step-tier approach, right? Instead of having two solutions, it's adaptive policy-driven access. On-net, maybe, so going back to normal, on-net user has access to everything. Off-net, but GP client, they have access to almost everything, but can do everything to the applications they have access to. BYO device, off-net, or even on-net, they can only do certain things to certain applications. So you can do that all through Prisma Access, single solution. And that's how it's routed through. And then it's on to the destination. So like I said, quick snapshot of our locations and countries that we operate in. And then STRATA. So when we talk about the firewall being just another consumption method of our firewall, this is what I'm talking about. All managed through Panorama, all logs to our Cortex data lake. That's our data lake that builds in machine learning for contextual awareness of logs and alerts and things like that. And all of the portfolio logs and uses Cortex, or can leverage Cortex for better detection and response. So XDR. Better security orchestration, automation, and response. So SOAR, we have capabilities around that as part of our portfolio as well. So some key takeaways for you all: comprehensive capabilities. We can deliver what a SASE is through a single platform that scales to meet the needs of today's business continuity requirements, and not only what's happening today, but in the future. One of the things that is quite interesting is over the last 8 to 9 weeks, we've doubled the number of users and customers on Prisma Access, and it's been done effortlessly. Our current customers didn't call us complaining, saying, wow, something happened a few weeks ago, everything's slower, right? It's all because of that instantiated data plane that we provide each customer, where there's no competition for resources and things like that. So that's where architecture does matter. Not all clouds are created equal. You need to ask yourself and ask who you're looking at for cloud delivered services. How does your cloud scale? Is it something that you have to scale by adding equipment, or is it something that you're taking advantage of cloud native services and microservices to auto scale this thing? Those are things that you have to understand. But then it's supporting all apps and users no matter where they are, right? So we don't care. It's not two products, internet security and private access to applications. It's just access. Data center, cloud, SaaS, web, doesn't matter to us. Users can be everywhere. Doesn't matter to us either. So with that, that takes me to the end of my presentation. So I'm going to kick it back over to Vic to cover off some of the next events coming up.
Awesome. Thanks so much, Jason. That was really insightful. At least for me, I learned a lot. So hopefully our participants are learning, and people who are going to watch our recording, they'll learn it.
That's great.
So let's talk about, awesome, thank you. Let's talk about next event. We have our CCSK study group week 2 tomorrow. So you guys will see meetup announcement pretty soon. Also, we're going to talk about the people who are getting into testing as a career, and we're going to talk about that on 15. Gentleman named Ron, he will be speaking, he actually spoke at the RSA about this topic, and he'll be doing a webinar with us. On 21st, we're going to talk about Zeek, how to install it on your home computer, how to start looking at it, and we'll also guide you through some of the signature patterns, how to look at using Zeek. And last event for this month is going to be DevOps security. So we started that journey earlier this year in January, where we started talking about CI/CD pipeline. So we'll have a follow-up session on 29th. So keep an eye on your emails, announcements, social media, meetup groups, so you guys can take leverage of these events. All right. So with that, we conclude our today's session. Again, all of this will be recorded and put it on our YouTube channel, and the slides would be available on our social media. People, make sure you are participating in the raffle so that you can qualify for that Amazon gift card. With that, thank you so much. Thanks for joining. Thank you, Jason. Thank you, Whitney.
Thank you all.